Oxidation zone. The product of pyrolysis zone has entered to oxidation zone. A predetermined amount of air is supplied and due to which combustion reaction takes place. That means exothermic reaction. The temperature is this zone is maximum reaches to 1200 degrees Celsius, a huge amount. D. Reaction zone. As the product of oxidation enters into this zone due to the carbon particle, endothermic reaction takes place. Carbon plus carbon dioxide, endothermic reaction. We find here the product 2 carbon monoxide. That means C plus CO2 is 2CO. Again, C plus H2, carbon plus oxygen, reduction endothermic, we get here H2 plus CO, hydrogen plus carbon monoxide. And from this two equation, we get here 2H2 plus C, that means CH4. Hydrogen plus carbon, we get here carbon CH4, that means methane, that's the biogas. Okay. So there is a picture of this process. Carbon monoxide plus hydrogen plus methane, and these are the produced gas. Air is going through this process. In the process, carbon dioxide in addition to water also add to carbon. There are so many ashes. Crushed solid feed solid water, drying zone, pyrolysis zone, breakdown of complex structure where temperature is almost 600 degrees Celsius. In drying zone, there are temperature of 100 degrees Celsius. In exothermal combustion zone, the air is coming through it, and here the temperature is almost 1200 degrees Celsius. That's a huge amount of temperature. It's so hot actually. And the endothermic reduction zone, there are temperatures of 400 degrees Celsius eventually. So there's the figure of this whole process. Now talk about biofuels. And this was collected from this website, that means Wikipedia actually, of biofuel, which was written on May 10, 2011. Biofuels are a wide range of fuels which are in some way derived from biomass. The term covers solid biomass, liquid fuels, and various biogases. Biofuels are gaining increased public and scientific attention, driven by factors such as oil price spikes, the need for increased energy security, concern over greenhouse gas emissions from fossil fuels, and government subsidies. Biofuels provided 1.8% of the world's transport fuel in 2008. Investment into biofuels production capacity exceeded $4 billion worldwide in 2007 and is growing day by day. According to the International Energy Agency, biofuels have the potential to meet more than a quarter of world demand for transportation fuels by 2050. Examples of biofuels: ethanol, methanol, biogas, biodiesel, hydrogenation derived renewable diesel HDRD, bioethanol. Biodiesel's physical characteristics. This was collected from this website and it was taken on May 10, 2011. See here the characteristics. Specific gravity is 0.88. Kinematic viscosity at 40 degrees Celsius is 4.0 to 6.0. Cetian number 48 to 65. Higher heating value BTU per joule 127,042. Lower heating value between per gallon 118,170. Density at 15.5 degrees Celsius 7.3%. Carbon 77. Hydrogen 12. Oxygen 11. Boiling point 315 to 350 degrees Celsius. Flash point 100 to 170 degrees Celsius. Sulfur 0.0 to 0.0024, a very little percentage of sulfur in biodiesel. Curd point -3 to 15 degrees Celsius and pour point -5 to 10 degrees Celsius. And this is the last slide. Implications. Biomass energy can be carbon neutral when all biomass produced is used for energy, short carbon cycle. But sustained production on the same surface of land can have considerable negative impacts on soil fertility, water use, agrochemical use, biodiversity, and landscape. Furthermore, the collection and transport of biomass increases the use of vehicles and infrastructure and the emissions to the atmosphere. Tolbert 1998, Burgess 1999, Faggi, Muleman and others 1998. Since worldwide climatic, soil, and socio-economic conditions set strongly variable demands for what biomass production will be sustainable. And this data was collected from World Energy Assessment 2001